definite integral from 2 to 4 of square root of log of 9 minus x over square root of log of 9 minus x minus plus square root of log of x plus 3 dx. This problem is from 1987, put that. First, I'm going to prove this lemma. The reason this is true is because if we can let x equal to a plus b minus t, so therefore dx is equal to minus dt. And when x is equal to a, t is equal to b. When x is equal to b, t is equal to a. Right, our new boundaries, right? b to a. Right, b to a. Now, so a to b f of x dx, this time should equal to b to a f of a plus b minus t, minus dt, right, minus. So get rid of the minus, change the boundaries, right, a to b. Exactly the same thing, right? Maybe perhaps replace t with x, right? As long as the variable is consistent, then we're fine, right? So this is really true. So in that case, a plus b is 6. Right? So all we have to do is to, this time the integral should be equal to, like I said, still 2 to 4. Right? We just have to replace x with a plus b minus x. The square root of log of 9 minus 6 minus x, right, over square root of log of 9 minus 6 minus x, plus the other square root of log of x becomes 6 minus x plus 3, right, dx. Right. That is equal to integral from 2 to 4 log square root of log, what is this? 3 plus x plus 3. X plus 3. The same thing, square root of log of x plus 3. Right, the other one, plus square root of log 9 minus x dx. So this integral is almost the same as the original integral, right? The same denominator, a different numerator. But if we can add them up, this integral, so twice of the integral is equal to integral from 2 to 4. Square root of log of 9 minus x plus square root of log of x plus 3 over square root of log of 9 minus x plus square root of log of x plus 3 dx. That's just 2 to 4 dx. That's 2. Twice of integral is equal to 2. Therefore, integral should equal to 1. Right? And the geometric interpretation of this integral identity looks like this. X 0, a to b. Right, assuming it's integrable. So this graph of f of x, right, for example, right, and the other function, f of a plus b minus x, right? It's not hard for us to prove that these two functions, their graphs, are exactly symmetrical according to this vertical line, this vertical line, half of a plus b. Exactly symmetrical. In other words, if the graph of f looks like this, then the graph of this will look like that. Right? Perhaps this. Symmetrical, right? But of course, their integrals should be exactly the same, right, from a to b. And this, in fact, a generalized version of the integral from negative a to positive a for an even function. An even function whose graph is symmetrical according to the y-axis. A generalized version.